Hello, welcome to this webinar on advances in indoor and sensor positioning. My name is Antti Jakobson. I'm going to be your host during this 2-hour webinar, which is organized by the Location Innovation Hub Fair and the Nemonoor. All of them are the European Digital Innovation Hubs. And we are very pleased to share these kind of experiences that we have within our EDIH on this, and also to share some use cases and to have a panel discussion. If you think about the program today, Tuomo, Malkamäki and Eirik Andreassen Tuomo Malkamäki from the FGI and Eirik Andreassen from the Nemonoor will start with introduction of the webinar, and then followed by the Tuomo and Toni from FGI on the what kind of test environment we have available for doing tests, and then experience from Nemonoor on the navigating without boundaries. Some use cases from companies, smart cities, Jenna-Riia from Sitowise, Finland, sensor position use case from Koherent, and Estonian and European use case from Indrek, Eliko. And then we've closed this with the panel discussion, and panel will be presented by Morten, Gustavsen, Teemu, Lehtinen and Indrek, and will be hosted by Frank and Nemonoor. So that's our program today, and let's start with the welcome and introduction, and Tuomo and Eirik, floor is yours.
Well, hello. I hope you can hear me. Warm welcome on my behalf. My name is Tuomo Malkamäki and I represent Finnish Geospatial Research Institute, which is part of a national land survey of Finland. And more precisely, I come from the Department of Navigation and Positioning, which I guess you can guess from the name that we are very heavily focused on navigation and positioning related research overall. The purpose of the webinar is, well, I guess we have the idea that this kind of webinar is timely, and the theme is important in the current research and industrial scenery, and we hope that this kind of webinar would facilitate and cultivate networking opportunities, new business opportunities, general discussion on the possibilities of the technology and what can we expect from the future, near future, and what kind of challenges we still have, and so on. I assume that a lot of you people here in this webinar today are quite familiar with the theme. For those less familiar with the topic, I would like to say that indoor positioning has been discussed quite a long time. So far, it hasn't really seen such a widespread use compared to, for example, satellite positioning in outdoor scenarios and use cases. But recent development within technology seems to indicate that we are approaching a moment in time where the solutions are either precise enough for new possibilities, or on the other hand, the solutions are cheap enough to enable mass market or consumer level adoption on a wide scale. Yet, on the other hand, it seems that we are still somewhat uncertain of what kind of commercial applications there might be. I'm hoping that we can today hear some interesting business perspectives as well as application ideas. But it seems that we are still looking for proper killer applications for a lot of, or for a wider adaptation of said technologies. That's my short introduction. I would like to give the floor to Eirik now.
Yeah, hi everybody, and thanks for inviting me to this event. I had some trouble logging on here, but I think I should be okay now. Can I just briefly share a presentation from you? Is that I'm not used to this thing here, but maybe this is the correct one. Just give me a second. You can just continue to talk while I'll try to hook up to things.
So, for this webinar, we've tried to gather people not just from Finland, but on a more wider scale throughout the Europe, and I hope we've achieved reasonably good coverage of different entities, both academic and industrial companies. So, please,
Perfect. Yeah. Thank you so much, and thank you so much for the invitation. I'll just give a brief introduction from one of the Norwegian EDIHs, Nemonoor. I guess EF is already part of this event here, and EF is one of the partners in Nemonoor. What our goal is to help private and public enterprises in Norway primarily to use data, digital technologies, and artificial intelligence. And what I've said initially here, it's always in collaboration with established networks and ecosystems. So we work very closely with the clusters, and two of our partners in Nemonoor are clusters. That is Ålesund Kunnskapspark, who has a maritime cluster, and Smart Innovation Norway, which has energy, decommissioning, and AI clusters. And sort of what this is from our side all about adoption of AI. So we try to encourage all the companies to have a clear value proposition, which I think it's much more important than actually saying you have to use AI, which I think is sort of the statement that is said many places. You have to use AI because it's good and it can help you with a lot of things. I think we need to start about what are these a lot of things that AI can help you with, and then sort of show them how can you use data, AI, and digital technology. And I think it boils down to both the understanding of the technological opportunities, the facilities that are available to you, and building what we call digital imagination and practical skills. So we have sort of provided a menu of services to help companies actually explore these opportunities from a very initial phase to improve what we call digital imagination, where we have basics of AI and basics of Nemonoor, because I think a lot of companies actually need to understand how an entity like an EDIH can help the companies. When I say basics of AI, it's both analytical and generative AI. It's both language models and machine learning that we focus on. So once you're sort of ready for the next step, we undertake a digital maturity assessment to more thoroughly understand the company's capabilities. But I think more importantly, the discussion, the dialogue we have with the company in this phase also enables them to understand their opportunities for using technology. We then have a service where we try to build relevant knowledge and skills within analytical AI. This can be everything from just understanding machine learning to actually learning Python programming. Generative AI, which can be everything from actually understanding how you can make better prompts until up onto how do you use language models in your own organization. We have a great focus on cyber and how to address the cyber threats, but mainly from the perspective where it's behavioral, sort of how you control this. And finally, on business development to understand how you can actually explore these technologies. When it comes to, what should I call it, test before invest services, they fall into two categories. It's either to use your own raw data in processes, and I'll show you a couple of examples of what we have done there. And then it's the use of language models on your own documents information. And finally, there is a set of services that helps you take the next steps in finding public, private EU funding, how to become or ensure compliance with legislation, and how do you find relevant networks, ecosystems in Norway and the EU. So this is sort of our service portfolio. It's a simplified version of it, but most of the services we have fall in at least one of these categories. So our target, and that is during the mobilization, where we use the existing ecosystems, because one of the things we have actually found most challenging is actually reaching out to customers. So we try to identify companies that are data-driven, or at least have a desire to become data-driven. And not the least that they have to be interested in exploring how data, technology, and AI can contribute to solving specific problems in their own business. They should preferably be part of a network or a defined ecosystem. It's not a prerequisite, but it makes life much, much easier for us. And it's also much easier for the network, cluster, or ecosystem that they can rely on a service provider that already come more or less fully funded for the services they want to take part in. So how do we work? Well, it depends a little bit on whether we work with individual companies or with clusters, but we always start with a conversation, dialogue, introductory meeting where we talk about Nemonoor, how we can assist you. We then undertake the DMA. We help you get started with the service, or we help you implement the service, and here you have a contact person with each of the services. And finally, we do an evaluation. With clusters, it's similar, but we then work through the cluster management. And for us, this is much more efficient, mainly because they already have the necessary, what should I call it, trust amongst the companies that they work with. So apart from that, the services are the same. The structure is the same, but we did now work with groups of companies, and we also have services where we put them together in a room, have them share their experiences, knowledges, how they work on deploying AI, what kind of value proposition they develop, and how they find working with AI on a more structured approach to that. So this is just an example of one of the programs we in Digital Norway have. It's sort of a competence program that lasts more or less 6 months, where we deliver tailor-made competence program to give a group of companies, could be, as in this example, the agri-food tech sector. We develop a dedicated homepage, we make available digital courses, we arrange physical and digital gatherings, we do a competence mapping, we write case articles about what they do, we promote their activities. And it seems like having a comprehensive view on not only how we help the companies, but how we can also help the companies show what they have done is very valuable. I've put the prices up here in Norwegian kroner. This sort of deliverable have a market price of around 200,000 Norwegian kroner. It's how much is that? 18,000 euros, something like that, 18,000 euros. And we give a discount of 80%, provided that this is mainly an SME group of companies. Other services, all prices here in euros. We have an AI assessment. This is a one-day program where we sort of look into the services that can be relevant for a company, their data, and how they can actually deploy their own data. We have a basic course for individuals in analytical AI. This is by one of the universities. We have workshops and courses on generative AI, where they sort of develop their own skills in prompting and in use of data within specific topics. The most comprehensive service we provide is a feasibility study for the use of your own data. I'll show you a couple of examples of what we have done for companies within this type of services. And we also help them with business development, the legal framework assessment, and use of LLMs in their own businesses. So this is one of the examples we have had. We worked with the agri-food tech industry, and unfortunately this is a Norwegian only, but I guess you have a AI system that can help you translate if you need that. With one of the companies, Circular, we helped them optimize their route planning based on the data they gather. This is a company that actually collects garbage from industrial companies. It can be from farms, could be from construction sites, it could even be from households, but that's not the main sort of goal for this project. But then we used data they have from the sensors on board the trucks, from the sensors in the containers they use for garbage and other stuff. And then we found ways to sort of help them use their own data to make a much more efficient collection process. The other one here is a company called I think it's called Norsvin, which helps farmers with semen for growing pigs. Sometimes piglets become what do you call it? They can't have any offspring, so we have to ensure that they don't become sterile. This is a quite cumbersome process where they have to sort of do a DNA test. They look into microscope. They look for specific patterns in the pictures. So we developed an algorithm and a process where they can actually use this kind of technology to identify cases where the piglets may become sterile, which is absolutely not good. So this is sort of a couple of examples. We're into many more examples now going forward, following up with these people here, but also having a similar approach to other clusters within the wood sector, industrial sector, aquaculture, and we're quite sort of neutral on the type of sector we work with. So typically you can find us on the website is Nemonoor. There you will find all our services, a short description of who we are, all prices I've shown you. We attend conferences and events where we either arrange these conferences or participate in conferences. We run specific campaigns where we focus on practical use of AI and how to address cyber threats for individual companies. These are very short 2-hour programs, mainly intended for, well, but first of all, to teach people something useful. Secondly, to actually help them engage with Nemonoor in further stages. And finally, we have dialogues with established networks and ecosystem through Innovation Norway, Siva, which is a Norwegian company that addresses particularly industrial use of AI. And we work through what I said, established networks and ecosystem, and that's the sort of main takeaway. So that was very quick and dirty from my side on what we do and how we work. So I'm not sure if there's any questions in relation to this or any reflections.
Thank you, Tuomo, and thank you, Eirik, for the welcome and introduction. Now we are going to move on to the next presentation, which is a little bit explaining what Location Innovation Hub is offering as one of its test before invest type of service. And Tuomo will start explaining and demonstrating that. Thank you.
All right, thank you. Like Antti mentioned, LIH and FGI basically have been working on indoor positioning test environment, and the idea has been to make this available through the LIH as a service that outside companies, for example, could utilize with a minimum investment in infrastructure. And I'm here with my colleague Toni Hammarberg, and we will give a short tour or briefing on what this is all about. Like Antti mentioned, this is just one of the things that LIH can offer, so please feel free to ask Antti or browse the LIH web pages for other similar possibilities. But so a little bit background about FGI and specifically our department. So me and my colleague Toni, we are working on the Department of Navigation and Positioning, and our department specifically has been working a lot on GNSS related topics throughout the years, but also on the other side of the coin, namely non-GNSS navigation and positioning tasks. We have a pretty good experience with essentially all the main navigation sensors, from inertial sensors to cameras, lidars, even to magnetometers, parameters, and things like millimeter wave radars even. We also do and have experience in sensor fusion. We are currently working on PNT integrity related topics. We have some reference system experience and so on. Over the years, we have developed or tested or whatever different things you can do related to different kind of indoor or similar to indoor solutions like pedestrian data reckoning from buildings, including food PDR type of solutions. Then we've tested different kind of vehicle solutions, from vehicle inertial navigation to camera and lidar-based SLAM systems. And then we have pretty decent experience on different radio frequency-based local reference systems, in addition to the GNSS stuff. For the past few years, we have been working on this indoor positioning framework. The idea has been to create this kind of modular test framework that would rather easily allow testing different kind of technologies, with the emphasis being on radio frequency, commercial or consumer type of radio frequency solutions, namely Bluetooth angle of arrival and ultra-wideband radio positioning solutions. We are obviously actively looking towards upcoming additions, for example, Bluetooth channel sounding and ultra-wideband angle of arrival solutions, which so far we haven't implemented, but probably will look into the very near future. Then additional sensors could be added to this system, and we at least evaluated camera-based solutions. And the idea for this whole testing environment has been to provide testing at 3 different levels. So perhaps the main focus has been on allowing or enabling companies to test their application ideas. And at least to me, the challenge with the indoor positioning technology has been to find attractive applications. So the technology is becoming quite mature, but the applications are the difficult part. At least that's the way I view it. And the idea has been to provide testing abilities for companies that have the idea, but not necessarily the infrastructure. But on top of that, we can of course test different kind of algorithms and software, for example, sensor fusion of different solutions. And of course, this type of framework allows also hardware and component testing at different levels. So basically, our framework allows us to compare and fuse different solutions. Now I'll give the floor to my colleague, Toni.
Thank you. So I'll be talking a bit about the technical capabilities, and as we are talking about the testbed, the point is not really to demo any single system or algorithm, but the point is to have a software framework which can be used to benchmark these algorithms, systems, and so on. And for the software, we are mostly using this robot operating system or ROS2 framework. And from that, we get some attractive features. So for example, we get this record and replay in time synchronous manner. So we can record the sensor data, then replay it, do some tests, possibly augment the data, everything in time synchronous manner. And then of course, this ROS has standard interfaces for data input and data output. So in that sense, it's easy to bring new sensors in or then take data from sensors and then fuse that data. We also get some visualizations, and everything that I've mentioned previously is not specific to indoors, so it could be used in any situations. But then when we are working indoors, we need some kind of indoor map. And for this, we have tools to produce a indoor map visualization from CAD files. So these CAD drawings are quite ubiquitous at the moment, or basically any building will have some kind of CAD drawings from it. And we can then convert that to first GeoJSON, and from GeoJSON then to a visualization. And it's worth noting that the visualization will have essentially all of the details that the CAD drawing will have. So if the CAD drawing is very detailed, if it has multiple floors or some 3D structure, then the visualization will have that as well. I think that's all from this slide. Yes, and this is a short demo about the situation. So what is happening here? Here we are visualizing some sensor data, some position solutions, and then the indoor map in ROS. The map and this data is from our Otaniemi offices. Basically, in bottom left, we have some camera footage of a person walking around in the office and carrying a few sensors. Then in the middle of the map, we have this green and red axes. That's basically the Bluetooth and UVB antenna arrays that Tuomo mentioned previously. These red arrows that are moving are essentially the angle of arrival estimates from the Bluetooth sensors. So they're basically pointing towards the direction that the user is. These gray areas or these balls, they represent the distance measurements from the ultrawideband. And then the small purple ball is the ultrawideband position estimate. Now that the smaller axis, which has the small text camera, I hope you can see it, that's essentially this type of infrastructure fee simultaneous localization and mapping algorithm using the camera. And important to note here is that the camera produces this 6 degree of freedom position solution, so you don't get only the position but also the orientation, and you can see how the orientation changes in that map view. I would say that the camera is perhaps the most accurate sensor of these three, but again, the point was not really to make any single very sophisticated or accurate algorithm, but to have this environment where we can visualize all of this data, get this data in a time synchronous manner, and then develop the fusion algorithms based on that, or benchmarking or anything like that.
Okay, so that was the short or brief introduction to our capabilities. We have done some consultancies related to this, and we are actively looking to collaborate with companies. If you have any good ideas or application ideas, you could contact the LIH office, for example, Antti, or even me or Toni directly. We would be happy to discuss different kind of possibilities in and around this theme, and any level of discussions are welcome. So please let us know if you have interesting ideas to test. Thank you.
Thank you, Tuomo and Toni. Very interesting presentation, I would say. And as Tuomo explained, we are, let's say, ready to help companies to start exploring this kind of test environment. And I have to also mention that the starting point from our services is free. So we would be willing to do test cases for free. And of course, then at certain point, we have to think about how to continue. But the starting point is, from our perspective, free. So thank you very much. I don't see any questions. If you have questions, you can write them, and then we can take maybe in the panel discussion more questions if they are coming. Let's move forward to the next presentation, which is coming from Norway. Morten will start on how to use AR on the visually impaired and functionally disabled individuals. So the floor is yours.
Okay, thank you. I've just shared my screen, I think. Yes. I will present some perspectives from the user side with some results from a user test in the presentation, which I have called Navigation Without Boundaries, a user study on empowering mobility through AR for visually impaired and functionally disabled individuals. And the project I'm going to present is a project called Veiviser, which can be translated to Pathfinder, which is a relatively small research project, which was funded by the Norwegian Directorate for Children, Youth and Family Affairs. The overall goal for the project was to ensure equal service access for all citizens in a municipality, regardless of disabilities or barriers. And the way we wanted to test this was to use a handheld demonstrator app using a mobile phone, featuring a multimodal user interface for indoor and outdoor use. And we did some practical user testing with citizens with disabilities, which faced linguistic, cultural, or skill-related barriers. So the project was had quite a lot of partners. The R&D in the project was done by IFE, the university college in Østfold, and we also had the R&D partner called OnSite Viewer. And on the user side, we had the municipality of Halden Kommune and the Norwegian Association of Disabled. So the project was run as a user-centered design project. So we did collaborate with end users very closely, and we developed an app in 3 iterations. During the project, we also defined a realistic user scenario, which we could do some user testing on. And during that process, we had quite a lot of interaction with the users, and there was clearly some needs and requirements that came up, and the needs was that there is a need for an application that has a higher precision than GPS. So they have tested outdoor navigation using GPS, and for people which are visually impaired, it's not good enough. It doesn't have the precise enough precision. And of course, it must be able to be used outdoors and indoors. And there's also a need for what I call a simple architecture to support indoor navigation. Usually for when the existing applications that uses a mobile phone for indoor navigation has quite a lot of sensors or beacons, which needs to be pre-installed. And when you translate that to a scale, it often gets too expensive. So there is a need for a simple architecture, and the solutions must also be GDPR compliant. So we had the close collaboration. We had identified some user needs and requirements, and we also did a feasibility study based on a system usability scale and an open feedback session. I will present the results later. So we considered 3 different technology platforms. So initially, we wanted to use the OpenAR cloud using the Open Spatial Computing Platform and GeoPose for the project. So very promising technology for this kind of application. It has a visual positioning system. It has privacy by design included in the technology platform. However, it lacked auditory feedback to the users, so we spent some resources on developing that. However, during the implementation phase, we found that one of the partners that we used for implementation was actually one of their endpoints in their cloud platform was located in Russia, and due to the ongoing war in Europe, we could not use that platform. That was not acceptable for IFE, which is we have very strict laws due to the Norwegian due to being part of being an institute that has doing research on nuclear safety. So we needed to find some other solutions, and we started wanted to look at software that IFE has developed ourselves, which was based on ARKit. So obviously we have no visual positioning system that restricts the test to a smaller area. We also lacked auditory feedback, but then again we used LiDARs quite a lot, and we saw that was quite a big improvement when we tested it. So even though the AR cloud and the VPS was very nice and gave us some promising results, we did have problems with lighting or testing the application in very diverse lighting applications and so on. The LiDAR did help us with that. So we saw that this was something that we would like to have. And During the project, we also found that there is a more specialized application called Clue, which is in fact an indoor navigation app designed for visually impaired users and can provide verbal, haptic, and visual cues. So that's inbuilt in the application, and that's also based on ARKit, so there's no VPS, so that restricts the test to a smaller area. But we had to modify it. So we decided to modify Clue and use that for the test. And the main things we did was that we replaced the text-to-speech to translate it into Norwegian, and we also made sure that some of the data storage was done locally. So, as I mentioned, we have this user-centered design process, and the users, they came up with a scenario that they wanted us to test, and the context for that test is that we're going to attend a wedding meeting at the town hall. So you are an invited guest with a disability that arrives in a taxi outside. And they needed to navigate to this room where the wedding is going to be, and that's in the second floor. And we had users both in wheelchairs and with very reduced sight, so that's kind of the user profiles we had. And we outlined some of the challenges, and that's, of course, we needed to help the user through an elevator, which we believed was quite difficult because using a SLAM algorithm or a VPS, there's very homogeneous wall surfaces. So we believe that might be a challenge in order to keep the localization of the user. We needed to make sure that we could avoid all tripping hazards for the users, and of course, this is also an urban environment. We did not know what to expect, and we also had some unexpected challenges on going from outside to inside. We were not confident that the sensors would drift. We know that the algorithm sometimes use GPS and not, and we were not confident that this would work. So, but we were yeah, of course very excited about this and wanted to do the test. And the tests, before the test, we had all the participants needed to do a very simple training scenario, which was pre-recorded on an Apple iPhone. And when the test was performed and they were a little bit familiar with the system, they could choose to use the Apple AirPods with a hear-through, or if they wanted to have visual or auditory feedback from the phone itself. There were only one of them that chose to use this AirPods with the hear-through. And as I mentioned, the following steps they needed to do is that they start outside at a taxi parking area. They navigated to the main entrance using augmented reality waypoints and continuous voice commands that they were giving us feedback. They needed to open the door and take the elevator. And when that was done, we did a system usability score test and a debrief. For the test, we had 6 participants. We had two participants in wheelchairs, one with multiple sclerosis and one with cerebral palsy. We had one that was 100% blind, which is a former guide dog user. We had an expert user, which was a trained mobility instructor. And we also had 2 participants with severely impaired vision, with a 10% vision. And one of them had 10% vision on the left eye and 40% vision on the right eye. So this is from the test. This is one of the users that has severely impaired vision. You can see that it's mainly using the auditory feedback, which you need here as a click. And each time he navigates to a waypoint, he gets some feedback. This can turn right, turn left, continue. There's some stairs, there's a quick and certain continuous.
Bruk døråpner på vegg til høyre, plassert under armhøyde. Bruk døråpner på vegg til høyre, plassert under armhøyde. Bruk døråpner på vegg til høyre, plassert under armhøyde. Bruk døråpner på vegg til høyre, plassert under armhøyde.
The elevator is to the left, so onto the waypoint, and it's onto the left. And here is one of the expected challenges that we expected is that going inside the elevator you actually lose the actual the position, because you're actually moving, but you have no feedback from the camera. This is one of the things that we were really concerned about. He's now using his fingers to find the second floor. Yeah, you can see that he's using and the VPS, or in this case, it's not the VPS, it's the algorithms. They are a bit confused because they don't think he's moving. This is standing still. So this is something that was expected, but it's in fact managing to do as the system So he's on the second floor, and he managed to find the goal. So after that test was done, all 6. Immediately after, we did a system usability scale test, and the system it helps measure user friendliness, and it does that by comparing different versions of a product and assesses how system performs relative to their competitors. This basically 10 statements that the user rates on a 5-point Likert scale, ranging from strongly disagree to strongly agree. And when you do that, you get a point from 0 to 100, where a score above 68 is considered above average. It scores in the 70s and 80s is really good, and 90 is excellent. It should say that the system usability scale is not diagnostic, so that means that it does not identify specific usability issues, but it gives you an overall look at the system. So that's why we had some specific or open-ended questions in the after the SUS test. And the results from this test shows that all participants managed to navigate to the goal without help. The average SUS score was almost 80, with individual scores ranging from 70 to 92.5. And so you can see that the low score we had was actually, this indicates that this is a good system to an excellent system. And if you had surpassed 80, that would have been too excellent. One interesting thing was that the participant who rated their technology skill level as high were more positive about using the prototype during the test. However, the study's very small sample size prevents from drawing conclusive inferences from the results. But yeah. We also had this open feedback session, and I added some selection of feedback from that. Most users thought it was impressive and fun and that the system guided users effectively. They wanted to have more feedback on dangerous areas. They wanted to have more feedback on the environment, even though the route was created in such a way so they were hindered from hazardous locations. They wanted to know about them. We also, as you saw, we forced them to use the elevator, and that was not. So 2 of the users wanted to use the stairs. They felt that was more safe because they could use the handrails. So an elevator is very difficult for them to use. They wanted to have a way to attach the phone to their body. So I know that the Østfold University College are continuing doing research on this, and they are doing studies on this specific topic. And we also had problems in the elevator. There is a lot of feedback to the user, so the audio instructions were not easy to understand. And one thing that we got feedback during the entire project is that usually they do a lot of preparations before they do navigate or move outside to places where they are not used to be. So typically they are sitting home using Google Maps or some other kind of map system to familiarize themselves with the environment beforehand. But we didn't provide them with any preparation, so that would have been make it a little bit more easier for them. Back again, they needed more detailed distance and height information, and they wanted also feedback on the surface type and elevation, especially for the wheelchair users. So to conclude, we have performed a feasibility and user test for users with reduced mobility and sight. We were not able to use a visual positioning system. However, we used ARKit for localizing user and navigation support. And our study shows, I believe, very promising results supporting the use of AR for navigation support for people with reduced mobility and sight. The system usability score was average was almost 80, with individual scores ranging from 70 to 95. And related to that was that the participants who rated their technology skill levels as high were more positive about using the prototype during the test. The open feedback sessions gave valuable feedback concerning future improvements. However, the study's small sample size prevents drawing conclusive inferences from the results. Okay. Thank you.
Thank you, Morten. Very interesting presentation, and let's say an extreme use case of the indoor positioning. But and also from the technology point of view, I think it was interesting. Morten will be sitting in our panel, so basically, if there are questions to Morten, he can take them during that session. So now we will move from the, let's say, more research-oriented type of cases to company cases, and what is the business in indoor positioning and sensor positioning. And we will start with the presentation from Jenna-Riia Oldenburg from Sitowise on smart cities. So the floor is yours.
Thank you. I hope you can see the presentation. At least it looks okay to me. So hi, my name is Jenna-Riia Oldenburg and I'm from Sitowise. Just a short introduction. Sitowise is a built environment consultancy company. We're based in Finland and Sweden, roughly around 2,200 professionals on infrastructure building and digital consultation. And I work as a senior consultant in our digital solutions department. I'm working with data platforms, digital twins, smart city services, and most of my customers are large Finnish cities or their stakeholders. I'm also doing academic research on the topic of data ecosystems in cities and urban built environment. And today, I'm perhaps talking about this phenomena from the other side of the value chain. So how do we utilize these technologies in order to bring cities and citizens and their operational environment more efficient ways to do various things? At the moment, we see the importance of sensor positioning perhaps mostly in these three areas. So urban mobility, which is a huge use case, and there's a lot of need to utilize real-time data from various sources to optimize things like parking solutions or congestion avoidance, and just kind of see the situational picture as well as the perhaps the near future of the state of the city. In addition to that, the resource management use cases are showing to be a bit more mature. Smart waste management is something that cities have been doing for a while. There are some sensoring solutions in water solutions, water infrastructure, energy, and property management. And all of this, or all of these data sources are increasingly being used to maximize or increase the data-driven decision-making in cities. As we know, the research is really active, and there is a bit of a phenomena here that we have a lot of nice technologies and use cases and pilots, but the the value chain probably still needs a bit of development to really find those use cases. And what I'm going to show today is sort of a story of use cases in a smart urban environment which involve sensor technologies and the data ecosystem data platforms and the ways to visualize what the sensors actually can do. We start with the digital twin for autonomous driving. I think this is from year 2020, 21, 22, where we, together with VTT, Nokia, and other research companies, as well as with City of Tampere, build digital twin on an real-life test site for autonomous buses. There's 3D, very accurate real-world infrastructure that utilizes city data models, real-time weather simulation, as well as the 5G wave propagation simulation to pinpoint where the automated bus, when it's driving, has the most trustworthy coverage of the 5G network, and where perhaps there are some dev areas or room for improvement. The model is, I use the term very accurate in a sense that it's not only LiDAR scanned and taken into the city 3D model, but it's also tested and verified to be, I think, under 10 centimeter accuracy. So if something is showing on the model, for example, traffic light post, it actually is there. So it's in coordinate wise also really accurate. And this is obviously really important when thinking about teaching this kind of autonomous bus, where to stop, where can it turn, what are the areas. For example, I don't know if it's visible in this image, but there is a school, an elementary school, shopping mall, and a couple other places which are really heavily populated. So those are interest areas for that really accurate sensoring and kind of seeing where the car can drive. The pilot phase has gone for a couple of years already, but there are new automated buses driving, I think, as we speak in this area. The same digital twin and the test area has also been utilized to enable city and especially people who are interested in testing these traffic data related things to see in real time where trams and other city owned or city operated buses and cars are driving. So this is more of a research thing, but also a way to see what is kind of the good way to build this kind of situational awareness and give understandable tools for operational planning in traffic as well as in urban planning. We have connected our digital twin solution, where the screenshots are from, directly to the city's IoT platform, and from there the near real-time data from traffic cameras and traffic lights can be used to show different sort of information and display, for example, on the right, how many different ways of transportation have passed through that traffic camera. And taking it to the next level, or towards the strategical urban planning, where I see a lot of possibilities to more detailed and kind of fused sensor data. We have built digital twin for future building plans around city of Tampere railway station, which is going to be a huge construction site for many years to come. And this model has now been used to engage citizens to communicate what they think about the designs. But in the future, we are hoping to implement also those real-time public transportation information, different kind of accessibility features, and perhaps AR and VR, in a sense that we could use the model to teach citizens new walkways or temporary pathways, and perhaps understand better how the area is actually being used. This could, for example, be done via Wi-Fi sensors or utilizing mobile phone data or things like that, and then combining them to indoor sensors about how many people move around and what kind of activity happens, for example, in the sports arena that's located in the left side of the picture, and then thinking about how that could be utilized in planning, for example, temporary traffic solutions or events or things like that. All in all, I think that the recent developments in data capabilities and the need to get more high quality, high fidelity and high intensity data for AI is something that's really going to drive this forward. We are going to need more tools to predict and prepare for things, especially in urban planning and sustainability, to identify things like high-risk areas for heat island phenomena in the city. We need more calculative power to the infrastructure in the city to be able to enable more accurate maintenance operations, analytics, and sort of predictive planning of, for example, the large events that happen in large cities. Disaster preparedness is also one of the topics that we discuss a lot, because we are expecting to see more weather phenomena or almost disastrous weather phenomena also in cities, and of course the other side of the security is there as well, like how we prepare for disturbances and plan for alternative routes or secure our infrastructure. And all of this comes to the need of the ecosystem of the data. So excellent solutions need excellent data, they need excellent processes, and they need like the collaborative take on the development of those services. So I think that the things like Location Innovation Hub and test sites and all of this collaboration is really, really crucial for us as consultants and we who work with the city to actually identify the good value chain from the good technology to right use case and to bring it all together. And I see a lot of potential there. I think my 15 minutes was up, so I thank you, and I'll stop the sharing.
Thank you, Jenna-Riia. Excellent presentation. Very interesting. I would have a lot of questions. Maybe I will raise one question that you don't have to answer now, but maybe that's a question for the panel to think about. That. Okay, I think there's a lot of potential, as you said, in the smart cities area, and we need this kind of ecosystems and data integration, sensor fusion, AI, and maybe the question for the panel is that why it's so difficult. I know perhaps the answer as well, but maybe that's a kind of challenge that we are trying to tackle. And thank you for raising the Location Innovation Hub as well. Sitowise is one of our partners, and maybe just one additional information that we are currently working on the Location Finland type of platform, where we actually have tried to put this kind of IoT type of data sources, which seems a little bit challenging at the moment. And I know that Nemonoor is also working with Fireware, with one of the municipalities in Norway with smart cities. So there's a lot of interest in this area, and we try to be working with this, provide this kind of test opportunities. So Location Finland is already running. So if you are interested, please contact me, and we can connect to that as well. And you can start exploring how you would be maybe testing that kind of information as well. So we have to move on. Thank you for excellent timing, Jenna-Riia. We move to Koherent. Kari Leppänen is going to talk about the sensor positioning use case. And I think we are waiting for a very interesting presentation from you. Thank you. The floor is yours.
Okay. Thank you so much. Let's go into my slides. Now I can share. Okay, so I will be also talking about the usage, but I also talk a bit about completely new way of doing radio positioning, which Koherent has developed, and maybe a bit of background. So our kind of technologies, actually it comes from space in the sense that I used to work in radio astronomy for 10 years in my past, and especially on very long baseline interferometry. And then after that, I worked still 20 years in wireless communication. So kind of putting these two things together allowed us to make a completely new kind of radio positioning system. So basically we took these big dishes and put them into small ice hockey puck sized disks, and instead of using millimeter waves, we use actually Wi-Fi band, like centimeter waves, and we have patented this technology. And so this, what we have done is actually, it's the most accurate 3D positioning, radio positioning system in the world. And a bit depending whether you want to do relative positioning or absolute positioning. So it has even 100-fold leap in position precision, for example, with respect to total station on certain kind of things. So for example, we are able to see movements that are smaller than the width of human hair from several hundreds of meters away, with using 5 gigahertz Wi-Fi band, and also then in absolute positioning we can quite reliably do, I would say, a few millimeter accuracy, outdoor and indoor. And it's not only about the accuracy; it has also other advantages. For example, with respect to optical systems, so it's all weather. It's actually quite easy to deploy, and I would say it's cheaper to deploy than ultra-wideband or Bluetooth systems. It can track fast objects. Even Formula 1 car could be tracked. It has up to 1 kilometer range. Now we have 200 meter range, but it's quite easy to extend it to 1 kilometer. It works indoors and it works outdoors. And maybe I at this point show you a bit of video. So let's do this. So I guess this is now visible. Okay, so this is a video that was taken in front of our parking lot, in front of our office. And we have basically for this demo, we have 4 antennas that are on top of the office buildings, and exactly these similar discs that I mentioned. And actually there we have 2, but we are only using 1 of those. And basically what we do here is that we measure from these the position of a 5th one that is there in the parking lot. So and it's based on measuring the distances of these links using these radio interferometry principles. So now what we do is that we start writing now with this antenna. This is 1 centimeter high writing, and on the left you see the tracking now from 30 to 70 meters away. So you see that the tracking is quite accurate actually. And actually we do it in 3D here. This demo is only showing it in 2D, but from such a distance doing such kind of accurate tracking is not kind of possible with any other technology. And we can actually do this in absolute sense. So we are able to kind of basically do the same in the whole parking lot. And when we return back to the same position, it comes back to exactly the same millimeter accurate position. Then next we saw a bit of a comparison with GPS. So this is kind of for case where we are sitting in one place. So these blue dots are GPS fixes from RTK GPS, the most accurate, and you can see there's quite a lot of variation. The green dots are from our system, and then also you see what happens in GPS, that it starts kind of drifting away because the satellite constellation moves and ionosphere changes and so on. But this is pretty good performance also from GPS. So if it would be moving and the reflections would be changing all the time, so that GPS would look much worse. And maybe this is of interest now for you for this indoor location case. So here we actually, in this one, we are moving our antenna with this kind of numerically controlled router. So now we are writing 5 millimeter high letters, and we have 4 antennas now in the room, in a normal office room. And okay, let's see. Looks like the video got stuck somehow. Let's try to redo it. Sorry about that. I hope it works. Yeah, now it works. I need to get back. Sometimes it's more difficult to get these video players to work than new positioning technology. So it's funny. Okay, just we are coming back soon to this video. So we are now using this NC machine to kind of write with 5 millimeter high letters in a normal office space, normal reflections. So we are able to track. Now this is 5 millimeter high writing, and now we are writing 1 millimeter high letters, and you can see that the tracking, again, radio tracking was that accurate. So that's kind of what we have achieved. And let's get back to this. So, okay, how do we use this then, this system? So first we have started to work on actually structural health monitoring, because we are able to move super small movements. So we have put these, for example, in bridges to see how the bridge is behaving under loading. And then the next thing that we are now kind of going to start quite soon is positioning in infra construction. So especially kind of machine control, seeing how the excavator is moving, especially in a city, in street canyons where the GPS or RTK GPS is not giving sufficient accuracy for this kind of machine control. The requirement there is basically 3 centimeter, and this is very difficult to do with RTK GNSS in cities, and of course in underground spaces it's impossible. So a bit about these bridges. So basically we want to extend the safe service life of the bridge and time the repairs correctly. There are over 200,000 bridges in Europe that are in pretty bad conditions, and only our technology can monitor fast and slow 3D movements. There are optical systems like robotic total stations, but they actually quite slow in measuring movements, 3D movements. So we can measure up to 200 times per second. So we actually see if a train passes a bridge, we can see exactly what kind of movements there are and what happens to the bridge after the passing. Does it end up exactly in the same position or not? And it works in every weather, again, unlike optical systems. And here is an example of what kind of accuracies we can get. This is actually from a real bridge in southwestern Finland. So there we see kind of, we are zooming from picture to picture. In one, we have kind of diurnal movement of a bridge, and there are these kind of jerks. So they are actual real things. It's because the bridge deck kind of gets stuck on its rubber bearings on old bridge, and then it moves in a different position. So you can see here that there's a truck is passing the bridge, causes it to move, and then it ends up in a different position. And then this picture number 3, we are kind of zooming in the kind of the vibration as it gets smaller and smaller. So you can see the scale of the accuracy of the measurement. So we are talking about tens of micrometers here. And this measurement was then 50 meters away. And this is not vibration measurement. This is displacement measurement with radio. Okay. And then briefly about the other application that we are now going into is this machine control and the why to use machine control. It's known to save from 20 to 40% in work costs and also in CO2 emissions from this digging. And the problem there is, as said, that it doesn't work properly in city centers, in street canyons, and of course if you have obstacles on top of you. But we were just today talking with Kreate, and they were trying in this Mannerheimintie to use machine control using satellites for 3 months during this Mannerheimintie construction project, and they just couldn't make it work. So there's a clear need for this kind of technology. Okay, so I think that's all I have to say.
Thank you, Kari. Excellent demonstration. I was very impressed about your 1 millimeter accuracy writing.
Thank you.
I never seen that before, so that was exciting. So also maybe one question to you. In a way, your technology seems very exciting. Is there, let's say, a cost element, for example, that would be involved here? That okay, it's only applicable for certain type of application, or what you would say about the cost of implementation?
Yes. Now, when we have the first version of our hardware, so it's even though it's based on Wi-Fi, so it's now with discrete components because it's specially built for us. And it's has an aluminium box around it, so cannot really use currently for portable applications. So that's why we are measuring bridges and these big machines, because they can easily carry this kind of stuff. But we don't see any reason why it couldn't be miniaturized. If you have a few million euros, so then you can put that on a single chip more or less, and then you would even have customer solutions in indoor spaces in the future. You would measure the positions of robots indoors with few millimeter accuracy. It's quite possible.
Okay.
Yeah.
Okay, exciting. Looking forward to see what you will achieve in the future on this area. So let's move on to the final use case example from the companies, and that comes from Estonia. And Indrek will be presenting how they are doing with use cases in Estonia, and I think you also will explain a lot of European and maybe global examples as well. So the floor is yours.
Okay. Yes, thank you. I am Indrek Ruiso, and just a moment to share my screen. Okay. To see? Okay. So let's talk about location tracking, and it's based on the ultra-wideband technology. So short background of the company. The company itself we started already 20 years ago, but last 20 years we have worked on ultra-wideband. Starting from R&D, we are building everything, including the protocols, but also hardware and software. And today, showing a map, we have different applications in different parts of the world. What I can characterize based on this map, that there are a lot of different applications in the different domain. We can talk about collision warning systems, but also improvement of car repairment, but also we're working of controlling underground truck movements. So the technology is the same, but still the applications layers are totally different. We are working today. So, but let's talk about the industrial applications, how it's used in industry. We can divide those applications with different areas. One, I think, which are quite important, we would like to control something, processes or movements in the real time or not. The both is possible, but in technology point of view, it's need a little bit different approach. Example, our solution, it's working on-premise. It means that all the calculations, the positioning calculation is happening inside server, which situate close to the production. If we're talking about statistics on analyzing of this positioning data, we can say that we can use cloud-based solutions, but cloud-based solution is not suitable for real-time applications. So we can divide this way also the applications we would like to do. But one exact application, how it's used. This is the production of large tubes. It means, you see, this is the tubes produced around this metal mandrel. So what we are doing, we're tracking these movements through all production cycles. And it's give to the company different insights. It could give increased efficiency because they could control all production cycles very precisely, but also it's influence the quality of production, as they know exactly how long, example, all cooling and heating cycles took time. Of course, it should be, or all the cycles are very precisely defined, but in real life, if in production the workers doesn't follow these rules, it's influence to the quality, and that's why it's important for the company know what's happening exactly in the production. Finally, what the company will get, it's get the overview. It's got the overview with 1 second accuracy, or if less, what exactly happened. And according to this information, they could make adjustment to the production, but also they could control the quality. And of course, they know exactly how much material they consumed per each tube they produced. So to control this, we built the network in this factory. We built so-called virtual geofences around each workstation. So when the tube reached to the workstations, we fix the time when it's entering and when it's leaving from this workstation. Of course, in the beginning of each production cycles, the tag, it's on the upper picture, will attach to each tube. It's the magnetic attachment. And this way it's just controlled through all production cycle. Of course, there are different applications, and this is the one how to measure and control the movements, and according to this data, they optimize the warehouse management. Again, there is the different possibilities to optimize route, and according to this, to increase efficiency. There is also applications and solutions what we are using. This is so-called moving geofences. It means that around the dangerous objects, which are where the tag is attached, we build different geofences. So when the geofences collide, it means that we can send alerts to the workers. as the workers as wearing tags connected to their helmets. So it's again a little bit different applications, but the technology is the same. But now jumping to the totally different application area. This is the entertainment. And this is interesting that starting this ultra-wideband positioning offering and technology development, we didn't think absolutely about this kind of applications. Today I see that this is entertainment area, it's quite increasing because there is many companies who are in the world who are using this technology to build so-called immersive experience. It means that the people's moving inside of some kind of show, some kind of play, they could get their experience according to their position. In this case, this is the one use case in the United States, in New York. It's the playground for children. And to starting this kind of use case, there are very basic needs from the customer side or requirements they are asking. It's normally the number of objects they would like to track, the area, the accuracy, and the update rate. And all this give, let's say, the first input to us how to build up this solution. In this game, it's additionally was important that we have the two-way communication, so we can send messages or change messages with the tags. The solution we made, this is so-called cosmetic play station, let's say. Our positioning is embedded inside to this play console. But what is quite interesting that what is the, let's say, most interesting and important that all this kind of solutions, they need quite a real-time actions and activities. And it's also some kind of challenge, especially it was beginning challenge for us how to do this, because if you have 200 players and 4 times per second, it's nearly 1,000 positioning per second. It means that it's not only the collection of the data, but also how to calculate all these events in real time, and then share these coordinates to the players. But today we can say that we have solved these issues, and it's working quite well. So the positioning applications, this is not only the positioning, but also the questions about the data exchange. What is the boundaries, or what is the, let's say, limitations of the technologies we have created and what we're offering right now? This is the one use case in the North Sea where it's used to measure the swing of the hook. So for us, it was this way a little bit challenging again, because our competition was GPS, vertical GPS plus image recognition. But the request from the customer side was that the positioning should be quite fast. And as our solution is working up to 75 positioning per second, it was something which satisfied their needs. But I think this is the one, let's say, most complicated case for us, because all the positioning is outside of this anchor area, and this gives additional technological challenge to us. But this is continuing, and this is some kind of sample how its indoor positioning could be used. So this is the ultra-wideband positioning technology. It's the same technology using different use cases. What I can see right now as the market, then the market is moving. I see that there will be more this kind of positioning fusion solutions where the example image recognition is used together with positioning technologies. They both have some kind of advantages and disadvantages, and what I can see, to put different positioning technologies together, it's give the real value for the end customer, and it's all also include example AI, that AI could be, let's say, technology or solutions which could give additional value for the end customer, as the positioning itself could produce quite a lot of data. It's a million of millions coordinates per one working day. To analyze this data and use this for the production improvements, it's not what human can do. So I think the artificial intelligence will be, of course, the one, let's say, additional technology needed for future applications. Okay, this was my short presentations about our applications, what we have right now in the world.
Thank you very much. Very interesting presentation. I'm very impressed about how you've been able to kind of create this kind of global business in rather short time. That's exciting, I guess, and it shows that there is a lot of use cases. I was also very impressed about your entertainment use cases in addition to the industry cases.
This is something new for us also, because we never thought that this will be used in this kind of applications around the world.
Yeah.
That's something interesting, but it's interesting on this area.
Okay.
Use cases, and maybe the killer use case is just under the corner.
Okay, interesting. So thank you very much. Thank you for keeping the time as well. Let's move to a panel discussion, so we have a chance to discuss about what we have seen here, and discuss about what to do in the future, what is the next steps needed. And in the panel there will be Morten, Teemu, Lehtinen from KIRAHub, and Indrek is also part of the panel. Tuomo Malkamäki is also ready to comment if needed, and the panel will be led by Frank Nemonoor. So Frank, you can start leading the panel.
All right, thanks, Antti, and a good afternoon to you all. My name is Frank Nemonoor from Location Innovation Hub, and we've heard very interesting use cases from applications for visually impaired to the gaming industry. I think we've now met Morten and Indrek, but I think I'll allow Teemu from KIRAHub to just briefly introduce himself.
Sure. Hi, everybody. My name is Teemu Lehtinen. I'm the CEO of KIRAHub. We're a national innovation hub for the built environment sector here in Finland, and also part of actually two European Digital Innovation Hub consortiums. So we have a bigger role in Finnish AI Region Fair, focusing on adoption of AI for the SMEs within the built environment sector. And then we're also part of Location Innovation Hub with a small role.
All right, thank you. So the panel has different perspectives. We have research perspective from the built environment, and a more technical background from the electronics. So I will start with you, Morten. You spoke about the application of indoor positioning for the visually impaired, which is very interesting. and we've heard more use cases in smart city and accuracy in positioning. But from a research perspective and looking into the future, where do you anticipate the strongest application of indoor positioning to be?
It's of course a very difficult question to answer. I think we heard a lot of very good use cases here today, and it's very difficult, of course, to predict which of them will be most important and successful. But from the research network we are using, we see that there is a big demand for integrating sensors for energy reductions in buildings using indoor positioning techniques for that, and also for healthcare. We do some research for, or we are indirectly involved in research for asset management using indoor positionings for healthcare. And I also think that there is quite a lot of need for that.
Yeah, and maybe I can then move to Indrek. Like, where do you see currently a strong adoption and application of indoor positioning?
I'm still quite confirmed that it will be some kind of production or manufacturing area. That it's not used. I see that it could be used. It could be it giving immediate feedback, influence to the production efficiency, and it's used to less right now. So I see that it should be one area which should increase quite near future.
And Teemu, what do you think?
Yeah, I think what we see this actually from two different perspectives. On the other hand, we see the kind of the user or human perspective here. I think there's still some room for improvement, how to build kind of even better services for wayfinding in buildings and city areas. There's still some spaces and areas that are not covered in Google Maps or other kind of free services that people use, but still they would benefit from guiding people to their final destinations, like large event venues or amusement parks or larger office campus areas, transportation hubs, etc. But then the other perspective is kind of this, what we have discussed quite a lot here today, is kind of the machine or robot perspective at how can we actually enable these new autonomous machines to operate in buildings and also outside city areas. So we actually are seeing more and more these kind of services happening, like delivery robots or other service robots, and they actually need some kind of positioning system or data to operate successfully. And sometimes they even have to kind of integrate to other existing access control systems like doors or elevators, etc. So I think these two perspectives are kind of important to keep in mind.
Yeah, interesting. And when you're talking about this sort of integration of all these services, what limitations, whether it's accuracy, software challenges, integration, existing infrastructure, what barriers technologically do you see preventing us from that future that you've just spoken about? I can start with you, Teemu, and then we can go to Indrek and then Morten.
Yeah, I think what we also discussed a little bit today has been kind of the cost of adoption. That may be a barrier at the beginning before kind of things have been scaled up. And so that's one for certain. I think it's other ways it's quite similar to any technological innovation. I know what is hindering the adoption is usually kind of the change management within the organizations and people. Often new technologies actually require rethinking of existing processes and even existing kind of logic or business model of services. And but many times firms or organizations are actually quite hesitant to take that leap and they actually even try to fit these new technologies to their existing processes, and that way they don't necessarily get the benefits that they would like to see, and that's of course one thing that's maybe slowing down the development.
Very good point on that change management. And Indrek, you can go ahead maybe from a more technical side.
Yes, I think that as there is many technology, not a single one, which could be solve all problem, that's a quite complicated to choose what kind of the technology is used for what kind of applications. It's mean if you're thinking about the consumer applications like for the navigations, you never need, let's say, 10 centimeters or millimeter level accuracy. To find the shop, it's enough 3 meters, 5 meters enough. But industrial applications, you need some cases 20 or less millimeters. So it's a totally different approach, let's say, and a totally different request. And then it's complicated to mix them together. And the customer side and the application builder side, it's difficult to choose what kind of technology to use in which cases and how to put those together. That could be one reason behind.
Yeah, and Morten, with what's being said by Indrek here, do you see that there could be any barriers in that you might be researching on that are stopping from a wider adoption of indoor positioning?
Yeah, from what we saw in the project I presented is that there is a challenge with the privacy and the data protection, and there is very difficult to have control of your data. In an application that we use where you actually use the camera in the public space, there's, of course, that's challenging because that's challenging the norms of privacy in public spaces. That's one thing, but also that you capture a lot of data that you need to make sure that you and, of course, the entire, all the people around you can make sure that these are handled in a proper way. So that's for the use case that I presented, that is of utmost importance.
Yeah, thank you for that perspective. And for my next question here, speculation is very much welcome. Do you see a breakthrough sort of killer application on the horizon that could drive a widespread adoption of indoor positioning technologies, and what could it be? I can start with you, Teemu.
Yeah, I mean, also kind of looking at kind of the human side and maybe the machine side on this one. I think we kind of started experimenting regarding kind of human wayfinding in many ways. We had some projects where we actually here at our space integrated kind of wayfinding inside a building to for example, lighting devices or these kind of physical cues when you walk through the spaces. But now that also the technology with kind of immersive technologies and augmented reality devices are soon coming more common and I mean maybe easier and not that clumsy anymore, I think the future looks quite promising there, where we can have these kind of visual devices or wearable devices that are almost as easy to wear as for example my glasses, and we can actually start painting our environment with data and also really having super easy to use services through that, or kind of the user interface through that. On the other hand, the kind of machine perspective, as we saw today with some of the examples, there's huge potential with kind of autonomous machine control in construction, infrastructure construction, building construction, but also in the service robots and kind of automating some of the services that we do manually at the moment with people. For example, all kinds of deliveries inside and out, cleaning, security, etc. So I think there's huge potential in those use cases.
interesting. Indrek, do you agree with Teemu?
Yes, generally. I might be able to add that, yes, I believe more that this kind of killer application is coming from the general navigation inside the building, that it's what everyone could use using their mobile phones, which not doable today. That there should be some kind of general application or technology. Is it related to the 5, 6G or 7G? I don't know that, but something like this. And there is a lot of different, let's say, modern applications, modern technologies, or let's say special solutions, which could be also growing up very large businesses, but still is little bit not so consumer oriented. Like all these navigation, HEVs navigations, they already navigate, but still it's not like the killer applications, but they are still the use cases, let's say. That's, I believe more that this kind of general navigation, that I have my mobile phone and I can walk around this large, whatever, train stations or shopping center in the unknown cities that find a way. That's I believe more.
All right, thank you. And Morten, from wearables and mobile phones, where do you see the killer application to possibly be?
Yeah, it's again a difficult question, of course, but coming from research institute that has focused a lot on AR, I think that combining augmented reality with precise positioning opens up quite a lot of possibilities, and very often you hear use cases that relates to urban planning, how you can visualize proposed developments in real-world context, emergency management, where you can assist emergency services. Use case I have with mobility, public safety, citizen engagement. Of course, you can use AR to facilitate virtual town hall meetings, and you can interact with proposed urban changes and so on. And we also seen quite a lot of examples for tourism, where you can overlay historical or cultural information onto landmarks. Yeah, that's some examples that we have seen, which I think is quite promising if this is implemented properly in a good technology platform.
All right. I mean, I still have 2 more questions, and for the audience, if they do have questions, they can just post it into the chat and we can ask the panel. Here I'll step a bit into what kind of collaborations are needed to actually support research, deployment, and commercialization of indoor positioning solutions. And here, considering the innovation hubs, the European Digital Innovation Hubs, what concrete steps can be taken so that indoor positioning systems can be adopted wider in industry? I can start with you, Morten. What would you say?
From a research institute perspective, of course, we would like to do more of the use case-based research. That would be something that I think we could help with gaining new knowledge about the topic. Of course, that would be very interesting for us. Yeah.
Yeah. Right. And Indrek, what do you think?
Yeah, I think yes. I think it could be related some way to this AI, because I still believe that this AI needed to be some kind of assisting layer or middle layer between positioning information and human, because we can create so many positioning information already today, and it's coming more and more, and you should be some kind of analytics layer. And I think this AI will be very suitable for that. That's, I think, this kind of help or cooperations.
So you think that the EDIH could focus more on giving this AI assistance?
Yeah, maybe something like this, or this kind of AI-based use cases, how to analyze this data. That's
Teemu, what do you think?
Yeah, I think EDIH in general provides super good platform for because we have a lot of them in Europe in different countries, even 4 of them in Finland, each of them focusing on certain topic. So they are already kind of existing networks, also quite large consortium providing services for SMEs and other organizations, so that they can kind of start their journey towards developing something and getting the expert help in different phases regarding training, testing, even funding, and then finding collaborators and even clients through the networks. And not just in one country, but all over Europe. I have to mention, for example, we are part of the working group construction within the EDIH network, where all the EDIHs that has the element of construction or built environment within their scope as kind of joined forces together, and we are constantly meeting and kind of sharing best practices through different countries, and then also starting to connect the local activities and networks more and more together. So it's a promising platform, but I think there's still quite a lot of work to be done to make it super successful, that leads to the actual success stories. So there's only been 2 or 3 years now that we have built this. So I think there's a promising future with that.
Mm-hmm. And what are some of the barriers that maybe you see in people who are trying to adopt indoor positioning, maybe in the built environment? Do you see any barriers to entry to using these technologies?
As mentioned before, I mean, I think it's just about having the awareness, what's available, what's possible, and then starting to experiment with those, and kind of trying to adopt these new opportunities within your own operating environment. So it's a step-by-step process, and of course organizations need support from different perspectives, and yeah, I think EDIHs can play a major role in supporting that.
Yeah. All right. We have 3 minutes left, and I have one more question regarding the testing infrastructure. We had a demonstration of a testing infrastructure from FGI. Indrek, what would be the ideal test infrastructure in your opinion?
It's as we are working in very different domains, it's quite difficult to explain, because we are working also under mine. So, but it's still, I think, what is the quite how to say? It should be it should have different options how to play together with this positioning, because in our case, as we are working in the radio waves working differently in different environments a little bit, and it's of course, and again, what is important, how it's how the positionings, different technologies could be connected to each other. I think it's some kind of options, because this is the trend I also see. So as test bed, I think yes, I can name 2. Let's say that one is that it should be possibility to play around with different environments, to move walls and so and so, and the other way that to test them together with different technologies. That's also interesting, and to see how it's act in different use cases. Yes.
All right. And last question here to Morten. Do you see any current gaps and limitations to real world validation and scalability of indoor positioning?
Yes, coming back again to the problems we had in the EDIH project, there is problems with the privacy and where to store the data and get the data from. For instance, if you doing technology where you need to scan a public building, where should that data be stored? Cannot necessarily be stored in a cloud platform using one of the big technology vendors, because you don't have any control of where the data is stored. So that's a clear gap from the use case that we had, is that we need more control of the data. Yeah.
All right. Are there any closing thoughts as we are out of time? Do you have any closing thoughts, Teemu?
Not really. I mean, I think we see more and more super promising solutions and technologies coming up that have interesting potential use cases within built environment sector as well. And it's kind of my mission is to help all those journeys forward and really make an impact to our life through those use cases. So
yes. All right. A big thanks to you all and to the audience. If you have any further questions, I think the panel will always be available. You can always get in contact with them from their various websites. Thank you, and over to you, Antti.
Yes, thank you very much, everybody that participated. I was very pleased about the excellent presentation, excellent panel discussion. I think there was a lot of thinking coming from your responses that we can exploit. Also, quite good feedback from Indrek from a testing perspective. And I think finally I can say that all the EDIs, as Teemu also indicated here, the Location Innovation Hub Fair and Nemonoor, we are kind of ready to help you, and basically we are also kind of providing each of our own expertise. And then finally, I want to say that what was also said by the panel is that the role of AI is something that we will exploit. I think all of us in the future more and more, that how we can exploit the AI in this kind of large use of data sets, and also integrating different type of data. I think we have also the feedback form somewhere that we can put available. I think, Frank, did you have the feedback information or?
Yes, there's a QR code in the top left corner that you can scan, and we'll also send a link in in an email.
Yeah, so we would be very pleased if you would fill in, put some minutes to provide us feedback, so that we know that what was good and what was not so good. Thank you very much. Thank you, everybody. So 3 minutes overtime, but thank you. Have a nice afternoon.
thank you.
Yes.
Thank you.